Hey guys, this is our first video lesson of the spring semester. We're going to be going over our parent functions. So parent functions are the functions before any transformations have happened. So you're not reflecting it, you're not adding or subtracting anything anywhere. It's just the very basic form of the function. Okay, so we're going to look at several different parent functions, but first let's look at the identity function. This is also known as the linear. This is also a linear function, but another name for it is the identity function. Think back to when we did identity equations, or we talked about what it meant for a linear equation to be an identity, and that was when both sides ended up being actually equal to each other. So you solved for x, and x ends up going away, and you get 2 equals 2. Or even if you had x equals x, that would be also an identity. So the reason that makes sense that this is the identity function is because we've got y equals x here. And looking at the table, you can see that the x and the y values are the exact same number all the way down. Okay, so they the two sides of that equation equal each other. You could think of it that way. So looking at the table, you've got x equaling y. Remember, f of x is another name for y. So you're just saying that y and x are the same number no matter which point you're looking at on the graph. And then graphing that over here, we've got points. The points end up forming a straight line. It is diagonal, slope of 1, y-intercept of 1. All right, what is the domain? So the domain going from left to right, because it's getting all of your x values, that's going to be negative infinity to positive infinity. And then the range going from bottom to top, that's your y values. Writing this in interval notation. Goes negative infinity because it's going to keep going down forever, up to positive infinity because it will continue going up in the positive direction. F of x equals x is increasing on its entire domain, which is negative infinity to positive infinity. It's increasing. That means it's moving up as you go from left to right. That means its slope is positive. And then it is continuous on its entire domain. Continuous means that as I trace this line, there's no spot where I would have to lift my pencil in order to continue tracing the line. So there's no holes, there's no asymptotes, there's just no break in that line. You could draw that entire line without picking your pencil up. All right, now let's look at this squaring function. So this is also known as the quadratic. Quadratic function, that's what you'll hear me refer to it as. Another name for it, though, is the squaring function because it's being squared, obvious reasons. Now looking at the table, you see that each x value gets squared to become that y value. Again, this is y equals x squared. So you're just taking whatever that x value is and squaring it to get the y values. When you graph those points, you end up with this parabola. Oops. Here, so you're saying 1 squared is 1, 2 squared is 4, 0 squared is 0, negative 1 squared is 1, and negative 2 squared is 4. If you kept going, you would have 3 squared is 9, so it'd be way up there, and then that would just continue up. So each y value is just the square of the x value. The domain, go from left to right, so you see an arrow on each side. It means it's, even though it is going up and getting, it's pretty narrow, it is going to eventually hit all x values, so negative infinity to positive infinity. The range, you've got the lowest point here is at 0. And because that's not an open circle or an arrow, it's automatically a point. There's a point there, and so you're going to use that square bracket. And then it continues going up. We've got arrows, so infinity. F of x equals x squared decreases on the interval. Okay, so remember that's where you've got a negative slope. I see the slope is negative. Slope is negative here from negative infinity to 0. So getting those x values, negative infinity to 0, getting those x values. And then it increases here to the right. We'll do that in a different color. It's increasing here, and that is from 0 to infinity. Sorry, should have put parentheses on those zeros, because at the point 0 it is neither increasing nor decreasing. The slope that at that point is actually 0, which is something you will learn in calculus. It is continuous on its entire domain, which is negative infinity to positive infinity. Yes, it is continuous. I could draw that without picking my pencil up. Perfect. Okay, now the cubing function, also known as just cubic. The cubic function. All right, so each y value is going to be the x value raised to the power of 3, which means multiplied by itself 3 times. So you see here you've got negative 2. Negative 2 times negative 2 times negative 2 is negative 8. Or just negative 2 cubed is negative 8. And then so on. So you get 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So these tables that we're running through, these should be values that you become very familiar with, so that you can sketch graphs just very easily. And also, you should be able to plot other points on these graphs by understanding how the x value is the input and that the y value is the output. So plugging in any x value, you can find that corresponding y value, which enables you to graph any function. All right, so here's what the graph ends up looking like. It's kind of like a narrow parabola where the left side got reflected over the x-axis. So you see 1 cubed is 1, so that x value is 1, the y value is 1. Then you go to 2, and that point is up there at the y equals 8. And then because negative values, when they're cubed, they are negative, you get negative 1 cubed is negative 1, negative 2 cubed is negative 8. So that's how you end up with that graph. The domain going from left to right, we've got arrows at both ends again, so negative infinity to positive infinity. The range going from bottom to top, we've got an arrow down here at the bottom, so that's negative infinity. And then the highest point you see is also that arrow, so positive infinity. F of x equals x cubed increases on its entire domain. Yes, it does. And then it's continuous on its entire domain. Continuous and increasing the entire time. So I do want to point out with the domain, we can use some of our prior knowledge from last semester to get the domain without even looking at the graph. So remember that our restrictions on our domain come from having a square root, or having something in the denominator, namely an x value of some sort, or a variable of some sort. So remember that we have x has to be greater than or equal to 0 here, and then x cannot equal 0 here, or whatever is in the denominator and whatever is underneath the radical has to follow those restrictions. Well, if you look at these three functions we've looked at, there's no fraction and there's no radical, which means the domain for all three of those is negative to positive infinity. Okay, so that really shouldn't come as a surprise, and you shouldn't need the graphs to figure that out, because again, of what we learned last semester, where the restrictions on the domain come from these two situations. All right, let's move on to the next page. We've got the square root function. Okay, so now I do see that radical. So now we should be able to say, okay, whatever's underneath the radical, which is x, must be greater than or equal to 0. So what do you want to bet? That is the domain of this function. So before we get to the domain, this is the square root function. Each y value is going to be the square root of the x value. So look at your table. The square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Now, whoever made this table was being very smart about it, because let's say you tried to put in x value of 3. Well, I don't know what the square root of 3 is. I know it's 1 point something there. So then I can't get the exact y value. So it's just smart to, when you're looking at the square root function, to only put perfect squares or values that will give you a perfect square in for your x values, right? Because then you can actually take the square root and you can actually get a whole number for your y value. Okay, the graph ends up looking like this. It is actually a parabola, half of a parabola on its side. The other half would be here, except we're only doing the positive square root, not the negative square root. Okay, so it's actually just the top half of a parabola on its side. There we go. The domain, going from left to right, if you look at the graph, starts at 0, goes off to infinity with this arrow. So there's the domain, exactly what we expected it to be, greater than or equal to 0, because of that square root. The range going from bottom to top, the lowest point is 0, the y value is 0, and then it goes up forever because you've got that arrow. F of x equals the square root of x increases on its entire domain. You can see that slope is always going to be positive. So from 0 to infinity, we have an increasing function. And it's continuous on its entire domain as well. It starts here, but it actually never stops as you keep moving on. So you will not need to pick up your pencil in order to graph that function. So on it. All right, now we've got the cube root function. So now notice we've got the index 3 right here. And each y value is going to be the cube root of the x value. So the cube root of -8 is -2, the cube root of -1 is -1, and so on. You get all of those values. Again, it's smart to put perfect cubes in for x. Oops. So that your y values are whole numbers. The graph ends up looking like this. Looks very similar to the cubic function, but it is laying on its side. And if you notice, actually, with the cube root and the square root function, if you look at the x and y values, and then compare those to what we had on the previous page, the quadratic and the cubic functions, you'll notice that their x and y values are exactly the same but flipped. So what I mean is the y values for the quadratic become the x values for the square root, and vice versa. So the x and the y values switch places, but other than that, the quadratic and the square root are exactly the same. And then the same thing with the cube root and the cubic function. They've got the same x and y values, but just switch places. So the y values become the x values become y values. Other than that, exactly the same, which is why their graphs look very similar. But of course, right here with the square root function, we couldn't have negative x values because you can't take the square root of a negative number. So we started at 0 and then went up to 16. Versus on this quadratic function, we did have negative 2 squared is 4 and stuff like that. But with the square root function, you can't take the square root of a negative, so you are going to start with just positive x values, which is why your domain is restricted to positive numbers. All right, now the cube root function, we've looked at the table, we've looked at the graph. What is the domain? Arrow, arrow, negative infinity to positive infinity. Remember that you only have that restriction greater than or equal to 0 if your index is even. You can take the cube root of odd functions. You can take the cube root of negative numbers, just not any even roots. So domain is all real numbers. Range, even though it's really skinny or really narrow here, the range is going to go eventually to hit all values, negative to positive infinity. F of x equals the cube root of x. It's increasing on its entire domain. You see the slope is, it's small, but it's very small, but it is positive, and then it gets more positive, less positive, but still positive the entire time. So on the whole domain, it's increasing. And then it is also continuous on the entire domain as well. All right, last part, absolute value function. So the absolute value, remember, is the function that is going to take away the negative value on the inside. So if you have a number on the inside of an absolute value, it becomes positive. It does not do the opposite and add a negative value to a positive number. Those would just both equal 10. And remember, what it is actually saying is what's the distance that number is from 0. It is 10 away from 0 either way. All right, so looking at the table, the absolute value of negative 2 is 2. The absolute value of negative 1 is 1. Just taking those negatives off, making the number positive. Then we've got 0, 1, and 2, 3 positive numbers. Absolute value of those is still going to be that positive number, 0, 1, and 2. When you graph those, it ends up looking like a V here, not a parabola. It is a V shape. On the right-hand side, you've got a line with a positive 1 slope. The slope here equals 1. And then on the left here, you've got a straight line with a slope of negative 1. Both lines have a y-intercept of 0, but their slopes are positive 1 and negative 1. And that is the graph of the parent function for absolute value. Okay, the domain going from left to right, again, we've got arrows on each side, no restrictions, negative infinity to positive infinity. The range going from bottom to top, we have a point at y equals 0. And then we go up and we see those arrows, so up to infinity. The function is decreasing on the interval. Okay, where's the slope negative? It looks like that will be on the left, the whole left side of the graph, negative infinity up to 0. And then it is increasing from 0 to infinity. And then it's continuous on the entire domain. I can sketch that graph without picking up my pen. So it's going to be continuous everywhere, negative infinity to infinity. All right, that's our video on these parent functions. There are more parent functions, but that's all we're going to look at for now.